So students, this is how we differentiate between our phase modulation and your frequency modulation. Fine. Okay, and when the conditions are identical, you know, PM and FM, your phase modulation and frequency modulation, they cannot be distinguished for single modulating signal frequency. Okay, so I hope this thing is clear with everybody. Let us now proceed forward. So next thing is, dear students, it is related to our FM spectrum. If you remember, we had discussed AM spectrum, and AM spectrum was very, very simple to you know, understand. And we had seen there that in case of AM, we have only 3 frequencies that were present. One was our carrier frequency, that is your FC. Then we had upper sideband, that is FC plus FM, and then we had lower sideband, that is your FC minus FM. Okay, so there were only 3 frequencies present in case of your double sideband full carrier amplitude modulation form. Whereas in case of FM, things are not that simple. Okay, so your AM expression was also simple, whereas in case of FM, our expression for FM is complex. So if I go back and I show you the expression, you see this expression of FM. So what do we have here? In this, we have sine function, and this sine function has another term of sine or cosine inside. So you can say that this is a sine of a sine. Okay, sine function of sine. So it's not a simple expression. So just by looking at this expression, we cannot say directly that this frequency is present here, because this is not simple sine frequency. So it is sine of a sine. So that's why we need to expand our frequency modulated signal frequency signal in a different way. Okay, so we use a new mathematical function that is called as Bessel function. Okay, and this Bessel function is used when we have sine of a sine. Fine, and we will expand our FM signal in frequency domain using Bessel function. Okay, so here we need not go into the details of the definition of Bessel function. Just for your reference, I have put the definition of Bessel function. You can see that your Bessel function is defined with your differential equation as shown below. And if you solve this differential equation, okay, then involving Bessel function, you get this solution. Okay, and this J and MF, this is your Bessel coefficient. These are different Bessel coefficient. Okay, and your MF is what? Modulation index. So this solution of differential equation, second order differential equation involving Bessel function, gives us Bessel coefficient, and these Bessel coefficients are in itself functions of your modulation index. Okay, so we are concerned with this thing only when we talk about Bessel function. Otherwise, we are mainly concerned with this expression that we have derived or that has been derived using Bessel function. So we need not go into the detailed derivation. We will just look at the final outcome of this solution of FM signal expression using Bessel function. So if you solve it using Bessel function, we get this term. So here, students, you see your instantaneous value of frequency modulated signal has been expressed as summation of different Bessel coefficient. See, J0, J1, J2, J3, J4, J5. These are the different Bessel coefficients. And these coefficients, if you carefully look at the frequencies associated with these coefficient, for J0, with J0, carrier frequency is present. With J1, you have omega C plus omega m and omega C minus omega m. With J2, omega C plus 2 omega m, omega C minus 2 omega m. With J3, omega C plus 3 omega m, omega C minus 3 omega m, and so on. Okay, so what does it mean? That we have, in case of AM, we had only two sidebands, lower sideband and upper sideband. And here, if you see carefully, your J1, it gives us first order of sidebands, your J2, second order of sidebands, then third order of sidebands, fourth order of sidebands, and it goes on, it goes up to infinity. That means how many Bessel coefficients are present in this expression? Infinite coefficient. Infinite coefficients means infinite sidebands. Okay, and J naught gives us the carrier part. So in case of your FM signal, we have the carrier frequency and the infinite side bands. That is the main important thing that you must understand here, that in case of frequency modulated signal, you have carrier frequency and infinite sidebands. And obviously, if we have infinite sidebands, how much bandwidth do we need to correctly transmit FM signal? So the bandwidth obviously that will be required is infinite. So theoretically, infinite bandwidth is required to accommodate frequency modulated signal. Okay, so though students, I told you that the quality of signal in case of FM is good, but FM is complex. And another disadvantage that we have just noticed is that infinite bandwidth is required, or at least much larger bandwidth in case of frequency modulated signal is required as compared to your amplitude modulated signal. Okay, so I hope all of you have understood this concept. So students, we will stop here with our discussion on FM spectrum and introduction to frequency modulated signal. And in the next class, we will talk about further observations related to FM spectrum. So all of you should read about the concept of FM signal, and then we will continue in the next class. Thank you.